Good morning, everyone, and welcome to my channel and to this new live session I'm starting today. It's a Saturday, it's a sunny Saturday, so I will be trying to speak for an hour, show you a few things, and then I'll go into my weekend as well. So I'll just wait a few more minutes for some more people to show up, but in the meantime, I'll be explaining what I am up to for today. So I tend to get this question quite a lot about integration, how would you do it? How are you doing it in production and all that? So today I'm trying to show you most of the things which you would need to do to get a more or less pretty good match. And this is just with my home system. There's nothing crazy going on. I didn't shoot any reference spheres or anything like that. I have an iPhone X from last year, so it has a pretty decent camera, and the camera is also very good. So it captures, like, I think it has a 1.8 aperture or something like that. So it should be pretty good, pretty decent to capture most of the things, especially for these kind of things. If you want to go into a more high-end render, obviously you would need a better camera to capture more light to get better references, for instance, or better light responses. Yeah, so that's definitely what we'll be talking about, and you can see already on my on the screen capture that we will be starting off a nuke. I just shot a parking lot, as you can see. It's fairly simple, but it has a few challenges to get it right, and I'll be just showing you guys an approach. I did something similar before, but this is a bit more now thought through. It kind of shows you all the steps and not just the lighting side of things. So yeah, hello from Turkey. Where are you guys from? It looks like people starting to join. Where are you guys from? It's kind of late in Europe or Eastern Europe already, so it's here. It's pretty early, so it's 9 a.m. So let's see, 21 people are watching. I hope the audio's good. We'll see. What else? First time find live. That's great. Yeah, this time I really tried to do it early. You helped me get a job at MPC as a technician. Looked about it. Wow, that's very great. I'm happy to have helped you. That's what I'm trying to achieve here, to get you guys into the industry and show a few tricks. Great stuff. And excuse my nose, I'm a bit not feeling that good. Yes, Arnold changed its logo. It's more like Autodesk changed the logo of Solidangles, yeah. Oh yeah, and before we jump in, I guess most of you know it already, I have published a course on Udemy, which is this bad boy. I have a special discount if you want to join, if you haven't done so already. I think that's a 50% off coupon. So if you have not joined, you can join this guy and learn a few more things. This is more, it's actually talking about most of the things in a very beginner way. It's introduction to shaders, where I'm explaining all the parameters of the most used shaders. I would say the same thing for the most used lights. I'm just talking about the parameters, and then I think as of section 4, the proper stuff starts. So I'm actually showing you how to create different kinds of shaders, blah blah blah. So it's very interesting. If you haven't checked it out, go ahead, check it out. Let me know how it goes. Okay, so audio is working great. Mexico, Rwanda, wow, great job. Is there any automatic? So what currently happens automatically, or what's starting to happen now, is denoising. So we don't need to render in full render settings. We just render low to medium, and then the denoiser automates or makes it clean, and it works pretty good. So that is Spanish, I guess. And if I could read it properly, it says, shouldn't you be using Autodesk products when not Nuke, or something like that? Anyways, so let's get going. We have, let me check how many people are joined. So we've got 48 people right now on this channel. So let's just jump into this. So as you can see, if I play this guy back, you can see we are in a parking lot, and this was just on my way to work. So I just walked past this lot and I thought, yeah, it's actually pretty nice lighting. We can actually try to get something going here. So to get an integration happening, obviously there's a few steps involved to get something going. Let me just move this over here and go to the directory. Ha, Julius is back in action. Hey. So the most basic thing is obviously you would need to have a plate, and to get CG stuff into the plate, you would need to get a camera. So the first thing most of the time is you would need to motion track this to solve a camera for this for your input video, right? So I did that already. It takes a bit of time, so I'll be just showing you what I did for settings, right? So that's my video, and the first thing I got to do is create a camera tracker and all that. I guess for compositors or people who know Nuke, this is a fairly straightforward process. Camera tracker, so I'm just showing you the basic things quickly. Right, so in the settings you can first of all visualize your features. So you can see we get these crosses everywhere, and this automatically looks for nice prominent features to track. So for each frame it follows these same points. You can see they get generated every time, and they try to follow the motion of the camera. Depending on your footage, you get a better or worse result. This is a pretty straightforward result, so it should be fine. You can play around, add more features. At some point too many is also not good, so there's a sweet spot. You can say minimum track length, so the higher the minimum track length, the more stable it gets, but depending how shaky or speed your videos, your speed of your video depends if it's possible. So for this, because it's such a long, just a walk actually, you can have a pretty long minimum length, maybe up to 20. Like it's 20 frames, so 20 frames should yield a pretty solid track actually. Or let's try 15. And then you have a few camera settings. So I shot it on the phone, as I said, so it's a free camera. I don't know about lens distortion. The focal length I shot is known. It's 28 for that lens I used. I don't know about the film back, so I did not really put stuff in there. So, and then I just ran I ran the track. It takes a bit because of this range, but what I can try to do is just shorten the range quickly. I think you can do that in here as well. Source range, so we can just do a custom range quickly. So let's just do what did I say for settings? I said 15. So let's do 30 frames. So let's start from maybe 100 to 150. So we are here now, and if I just hit track now, you could see that it starts from 100 and it follows these the features follow. Pretty simple stuff so far, and so you can see it takes a while, so I don't really want to show the whole range. It goes back to 150, and it goes to 150 and then back to 100. And once we have that, you can also add user tracks, which is like prominent. Like if you have put on markers somewhere, you can track them so you know exactly some measured data and stuff like that. I did that for the camera tracker because I kind of knew a few distances and trackers I wanted to definitely keep. So that's the Nuke tracker. Okay, and you can see now we have a few solid tracks here. You can see they definitely have a long trail, which is great. And then the next step would be to solve it. So if I solve it for that frame range, I would just hit solve for now and we'll see what we get. I think that's done already. Yeah, so I think the solve is already done as well. And depending on your error rate, you can see what kind of solve it is. So I think error of 1.5 is okay-ish. I think below 1 is very good, but it's still solid. It's still very good for what I just did. I did not really play much of these settings. So once you have your solve, you can go to auto tracks, and you can actually display your max track error and your minimum errors and your max errors. And if you frame this, you can see that my max track errors here, and in this frame range here, we get lots of errors here, I guess because it's very shaky at that point. So what you can actually do, you can reduce the max error if you want. So you can see it's pretty up high. So if you reduce this down, and you can then delete rejected nodes, points, and you can see you should get less errors. So it removes a few trackers, but you should get a lower error rate. Depending if you deleted too many, you can see it's now on 1.3. If you delete too many, you can definitely make a worse result, right? So that's kind of the logic behind the camera tracker. And then you can create stuff. So you can create just a camera, you can create a scene plus, which gives you point clouds and everything. So let's do that and just hit create, and you can see it outputs me lots of cool things which I can directly see here. So first of all, we get a camera with our point cloud, right? And it's a fairly decent track, honestly, for that kind of effort I spent. So that's pretty cool. You get a lens distortion grid, you get scene scanline renderer, and also what you can do now, if I just look through my camera tracker again, I can also pretty easily, let's just see why I don't see anything here. There we go. So what I can do, I can click on any spot which I think is a good location. Let's say I just take this one. I can right click, and I, for instance, could just create a cube at this location, which needs to be hooked up to my scene. And this is very important for reference points. So obviously the scale is now way too large, but you can uniformly scale it down to put it right there where you want it to be. And then depending on where you pick the point, you need to offset it a bit so it's located on the ground and all that. A few more tricks is you can specify distances, you can specify axes if you know them. What I mean by that is coordinates are in XYZ space. So what you can do here, you can specify and tell the tracker that these 2 points, the lines of these 2 points are aligned in a Z axis, for instance. So I'm thinking of this line and this point. It's not perfect because we don't have a great track for Z. Ideally, we would have a spot right there, and then we could say, hey, this is the Z axis, right? Let's see if we have X axis. We also, well, this could be kind of an X. Like if you say, okay, let's just say these are the X, it's the X axis. So I select both tracks, right click, and then I can say set X, and I can, so this is just aligning our viewport or our points in general. Then we can do Y. Let's see if there is something which could work. Because I have so little amount of trackers, we can't really do that. In my other tracker, I have a lot more. You can see, so in my other tracker, I use these two as my X-axis, I use these as my Z, and I think somewhere on the left here, this and this, I use my up Y-axis. So this is kind of how I set it up for the solve now. And then what you can do, let's go back to our tracker. You can say, okay, let's say a car is, I guess, 2.5 meters or something. So you can select these points and say, okay, I guess this is maybe 3 meters or maybe 3.5. So obviously on set you would measure that. I just eyeball it, so you can actually, where did I do that? Scene add scale distance. So that's what I just did. And then in the scene, you have a measured distance of 0.18. But if you know the real distance, you can just say, okay, I measured let's say it's a value of 3. So this is now a measured distance of 3 units. And based on that, your track or your scene in here gets updated. It gets a lot larger then. And you can see that all these guys should actually be on the ground plane. Right, so all these dots should actually be flat on the ground. So what you can do is you can say set origin or set a plane and all that, depending on the points you select. So if I'm sure that these are all on the ground, I think you can just do set to selected. Was that how it worked? Yeah, so now you can see it's all aligned, and now all these points are on the ground plane, and my scene is pretty much aligned. After all that, you would hit export, or you would actually create a right geo node, and you would select the scene like that. And depending what you want to export, in most cases Alembic is just fine. You have all the options to export point clouds, geometries, cameras, and axes. But another trick which I used, which is very helpful, especially if you want to do a proper integration, you can solve for a point cloud, like a point cloud generator. This guy expects a camera, which we solved, and it expects the source, which is our QuickTime right there. And based on that, it will create a different kind of cloud, like point cloud. So we just want to be, I think, in 100 to 150 range. Can we define it in this one? Let's just quickly crop the range to be 100 to 150. And in the cloud generator, you could do just analyze, and it would analyze your footage. Did I do that? Okay, there we go. So it takes a bit of time. In the meantime, feel free to ask any questions if this workflow is not really straightforward. I'm following the chat, so let me see how that goes. Yeah, so it's analyzing, it's looking for keyframes, and after that we can actually do a dense tracking, and then it generates point clouds, which we then can use in the end to kind of create a generic, like not a LiDAR, because the LiDAR is a different technology, but based on this point cloud, it will generate us a mesh, which we then can use exactly to place geometry in our 3D package. Oh, it's actually doing the whole range. That's what I feared. Let's see. Yeah, well, it's doing it now anyway, so it's 48 seconds left. And once that is done, we will be exporting that, the camera and the geometry. And then in Maya, which I can actually open already, we do the other cool things. Also, I will show you a quick way how to get spherical panoramic images. Also, I use my phone to create this, so I went out there to the same location, and I actually shot like a Google Street View 360 degrees image, which you can do with the Google Street View app, or I guess there are tons of other apps around as well. Okay, so let's just jump ahead quickly to Nuke again. So it analyzed the keyframes, and now what I can just do is I can just track the points in that range. So it's just doing that quickly, hopefully. Insert additional keyframes. Okay, because my range is maybe too small, it did not get enough keyframes. But anyways, I can just show you what it resulted in. So the point cloud generator, then when it's done, it spits out something like this. So this is a pretty dense point cloud with all my important feature points, right? Let's just, why is that? Okay, well the question was, can't we export it as a MA scene instead of a point cloud? Yeah, well, if you export it as Alembic, you can just import Alembic and you get all your geometries you set up here. But now comes the cool thing. So when you have the point cloud, then you can create a Poisson mesh. I think it has been a while. Just looking through that. And this uses all these feature points to create a very dense mesh around all this stuff. You can see now, just based on these clouds, on these point clouds, we have a vehicle here, a vehicle there, we have my back wall, and depending on how many points you have, you can see the density changes. So the higher the density, the more points you get. So you can see here is a big density, so that's very accurate. At the bottom is a lot. And then you can just export this with the right geo node. You can easily just export geometries and all that. And that's exactly what I did. So let's just head over to Maya. Lovely scene there in the background. So, alright, so this is my Maya session, empty scene. I'll just save it for, let's just do scenes. Okay, so this is a working scene I set up yesterday. And this would just be, let's just call this live setup. Cool. Yeah, feel free to ask any questions, right? Like I have the chat open on my second monitor, so if you have any questions, just shoot. Okay, that is that. All right, so let's just do it anyways. Okay, so now what you would do is I will now import my scene I used yesterday, or at least the Alembic stuff on that end. So import Alembic. It's on my desktop for now. It's in Nuke. So this is my exported stuff. So here's my, I think, let me just quickly sort by modified. Yeah, so I guess this should be the mesh. So that is the point cloud or the geometry. So I can use that in Maya already. It's black because the normals are on the inside, which is totally fine. And the camera here, I just rendered out a static frame, so this does not move, so I can just delete this camera. I had a few more like a different caches, so that's why I have a few in here. Import Alembic, and let's see, that's the point cloud, that's my geo. I'm currently not 100% sure which camera actually I took in the end. Is it this guy? Yeah, must be this one. So you can see now there's my camera. That's the one I tracked, and then I also exported a few meshes. So if I hide this was my first setup to get the back plane, and so I was generating a cube and nuke and exporting that. But now I have this nice Poisson mesh, so I don't need the rest. So to prepare the scene, I first had to clean it up for sure. So I had to go in the like side view or something and just delete this top stuff. Like this, and delete these guys. You could push this into ZBrush and do some sculpting to clean it up even further. So let's just do that. And obviously don't get rid of too much, but most of this can definitely go. These guys go. So because we use a spherical projection at some point, we still want to capture a few of these things. Right. So let's do that. All right. I hope this makes sense what I'm trying to do. So this is like in production, you would not need to obviously do the nuke step where you would generate point clouds and all that. In most productions, you get provided with LiDAR scans. It's a different technology to create 3D surfaces. It's very accurate, and you get a very high dense mesh back. But this kind of resembles that. It's not exactly the same, but it's a similar kind of thing. You get a LiDAR scan, and you have your chrome spheres, and you would just project the image onto them to get a better response. The question is, so did you use Nuke for camera track and generate mesh? That's exactly what I did. So I opened up Nuke, I did a camera solve, and from the camera solve I generated a point cloud, and from that point cloud I could generate this mesh, and then I just exported the whole scene as an Alembic. Alright, so the next thing is, what I like to do is go into the sculpting tools of Maya and just maybe make the mesh a bit smoother, or extend it somewhat. So that's what I'm doing right now. So before we do this, the Poisson mesh generates a few non-manifold geometries. So what you can do, you go to mesh and you can go up to cleanup and just hit cleanup. It takes a bit depending on the mesh you generated. But once that is done, what you can then just do is you go right click, sculpt tool. It's all converted into mesh. You can hit shift. You can smooth out these edges here. You can see now I'm doing some little sculpting in Maya. Not too much though, because I still need all the features on it. But what I like to do is just extend it. So if I view it from the top, especially the foreground stuff, I would like to just move the points outside, make it maybe a lot larger, something like this. Right, so all I'm doing now is just extending the geometry to get a bit more surface area. But I don't want to move these prominent features which I need to be exact for the track, right? So there's something you need to take consideration of. Don't move everything as you wish. You need to keep these prominent features in their accurate location. So if I look now through the camera again, hopefully we should have a good representation. Yeah, it's good enough. So you can see now how this works. So this is kind of exactly what I generate, or like how I walked and filmed. Pretty shaky stuff, but it's working. Right, so based on that, let me think what we are still missing. So we would need to get the spherical camera. The first thing is, let's just start with the projection setup. So yeah, let's do that first. So back in new quickly. Here is my spherical image. So I shot this. And I actually made sure I'm right on this this hole here, manhole, standing right on it, and just doing the spherical image. So I was standing there in the same location and just rotating to get all the angles. And once that is done, I uploaded this to Google Maps with the Google Street View app. I'm not sponsored in any way. I'm just saying it's a good technique to do it. So, and then you have the sphere right in Google Street View, right? That's the same one I used, and you can go there right now. You can just copy and paste this into the chat actually. Let's see if this is, why is it not going? Too many characters or what? No, it's really not letting me save it. Let's see if I can share it. Share. Okay. There you go. So that's the map. You can just go there, and then there's a software called let's just see, Street View Download 360. It's a desktop app. You open it up, you enter this link, and you get almost like a 15K high resolution download of exactly that map. Let's just show it to you in. So this is what I get, and if I show you the properties of this, it's 42 megabytes, and it's like 8K by 4K, so it's very huge map, and I just use that. Oh, and by the way, you can actually follow along. All these things are uploaded to the Patreon, on my Patreon channel. Right, so you can just use that to follow along. Also the video which I captured is on there as well. If you want to get that, if you want to track that, it's all on the Patreon channel, by the way. Which you should see in the cards. If you click on the right on the video, there's this like these cards roll out, and then there's this Patreon link. So back to here. So I've got my spherical. I reformatted that from 8K down to I think 4K. So this map is not an high dynamic range image. I shot it with my phone, so it's definitely clamped to 1, right? So it's not an HDRI, it's just a spherical image. So that's very important to keep in mind. Yeah, so I think I answered just the question. What camera did you use to capture the HDRI? Phone, blah, blah, blah. So I use a phone. It's not clamped. Oh, it's clamped. So that's something I'm doing here to kind of fake HDRI. If you have a proper DSLR, obviously you would do it in at least 3 different angles with a fisheye lens, and you would capture different HDRIs, so different exposure levels, right? Okay, so that's this, and then I just reformatted that, exported a 4K image. So this is kind of what I did for the projection stuff, and you can see if I stop down, you can see how clamped it is. So it's not a good HDRI. It's just a spherical image. What I did then is kind of to fake an HDRI image. I used a Luma Kia to get certain bright spots. I did some paint adjustments on that. You can see it's on which frame was that? 175. Sorry. On 175. And I did some cleanup on that roto like this. And then I went back to my image and I just played around with the exposure. So for this, I made it 1.5 stops brighter. And what this does, it kind of fakes dynamic range, right? It will give us more information on lighting. So you can see if I stop down and I enable and disable that, you should see that there is definitely more light now. And I did this a few more times, reduced the background and all that. And then I re-exported this map. Okay. So now back in Maya, what we will do now, we will just use this as a projection. So this is my setup. And if I open up the node editor and Arnold render view side by side, I select the mesh. And I'll just create a flat shader at AI flat. And select the mesh and assign that. I'll change my render resolution. I know it's just a typical HD resolution like that. I'm locking this. Render settings is very low, progressive off. Let's just do this to 40 threads only. Save, and let's see what else. Progressive on. Okay, hit play. It complains there's no lights in the scene, which is totally correct. I don't have any lights in the scene. I have a flat shader, so that's all I have. So the next step would be to create a file in a projection, and I want to have a spherical projection, right? Because I just shot the sphere and I want to project that onto my geometry. So in projection, first I choose my file, I look it up, it's under my source images, and I'll just use the edited one. So this is the one I already used to do some more lighting on this. Open it up, change my projection mode from planar to spherical. I think I need to flip it and all that, but let's see what we get. We don't get much because it's not hooked up. So out color from the projection goes into the color of the flat shader. There we go. So this is currently what we get. Let's just move this over. And you can see now this is my projection. And I said I know exactly why I shot this. So it's important to write it down, or to remember where you actually where you shot the sphere from. So I know it was between these two cars, somewhere around this location. So let's just place it right there. And you can see now that it's on the floor, so it's doing it from the center. I know I shot it kind of up to my chest height, so it's kind of a height of 1.5 meters or something. So just by moving this up, this is now I think 2 meters high. You can now see that my projection, it's stretched, but in that location, it's pretty spot on, right? You can see it looks pretty cool from that location. A few things though, you can see it's not matching, it's not aligned properly. So I think it needs to be rotated by 90. So it's actually this wall is this wall which I shot. And the other thing is it's flipped. So in the x-axis, I just do -1, and now it's flipped to the correct side. And now you can see that the long wall there is right in the back. And you can just align it, kind of thing. And this is a projection, right? So keep in mind that this is not a HDRI or anything like that. And also comparing this to my plate. That's the plate. And if I step through this, you can see the big car is on the left, the wall is there and all that, right? So I would say you can spend a lot more time on really aligning this properly. You can see how it's going around the surface here. This might not be perfect. I spent a bit more time in my test example scene, but yeah, this is kind of what the spherical projection is. So another cool thing, which it's kind of like a you need to think about this. It's a bit of a hack, I guess. Or not a hack, but you just need to understand what's actually going on. So in real life, if you have an object, you would see that it's actually being occluded, right? So if the car is here, the shadow and the occlusion of the car is blocking the light, so there will be no bounce light in that location, right? I hope that makes sense. So if I create a plane right now, let's say this is the bottom of a car. And I move it up here, you can still see that in my output window, that is not occluding. So whenever I have it, the bounce from the street will still light up the cube, right? And that's something which we need to like fix, right? So the trick is to go to your node editor. Very simple fix, by the way. You have your shader, you've got your projection. All you do is an AI multiply. And you do an AI ambient occlusion. You delete the shading engine. You hook up the occlusion out color to input 2 or 1, doesn't matter. Multiplication does not care. And you hook up the projection image. And then you hook up the out color to my flat shader. And now you can see something is really weird, which is very weird. I'm not sure why it's blue. That's just, I guess this is not out color. What did I pick here? I picked image or something. So it needs to be, definitely it needs to be out color. And now you can see that the cube is actually occluding my projection image. Right? So whenever I move the cube, you can see if I make it invisible to camera, so I go to render settings, primary visibility off, you can see now that actually when I put an object on here, it will not it will block out the bounce light. So this is definitely helping quite a bit in terms of integration. I hope you understand the concept about this. And the next thing is we have a camera, right? So we shot this plate. We want to project that as well, because this is the most accurate representation of the scene we can get. And then as a secondary projection, we would use the spherical one. So this is kind of a layered projection system. So let's head over to the node editor again and do kind of the same steps. So we hook up a file, do a projection. This time though, we don't do a planar projection, a spherical, we do a perspective. And we choose our camera, which is called object in this case. We want to match the resolution gate. And in the file, we would choose our plate. And I rendered that out. It's a JPEG sequence. It starts on 1 right here. This is the same image. I know it's a JPEG, so be sure to tick the color space to be sRGB, enable sequence. And now we should be able to see that when I project it. So instead of hooking up this setup, I just want to hook it up right now from just the camera projection. Render this. And now you can see that this image here, it's still looking through the perspective, by the way, is being projected from my camera, from this camera here. So if I would look through my camera at render times, you would exactly see the plate. And this is what we see, right? Exactly this image here. A projection of the plate onto the geometry. But I want to make sure it's not duplicated. It does not create these funky things in the front here. So all that needs to be fixed. So in my place 2D node, I don't want rep U and I don't want to rep V. Excuse me. So now we get this kind of thing. You can see it's white here, which is not really what we want, because if you would have a big sphere here, you would see a white reflection. So definitely something which we need to address too. So back in the node editor, in the as a projection, I think in the projection is a default. Okay, that's not it. Dang, did I break it now? No. I think in file then, let's see if it's in here. There is a default color, this guy. And what we want to do in this default color, we want to connect our spherical projection into the default color. So if I just grab projection, which is the spherical at the bottom, and I just drag this guy over to my default color, what you can see now is that the spherical projection is underneath the plate projection. The cool thing about this is we will always have data wherever we project things to, and we just need to fix the front thing. I think we can do the same just by plugging it into the projections default color. Let's see if that works too. And it does. So now we are fully enclosed by the spherical, and only for the exact camera we have our plate. I hope that makes sense. Let me know if it does not. Like as I said, I'm reading the comments on my second monitor. So let's see if that's clear. So to illustrate this even better, what I can do, I can create quick geometry again. Let's just do a sphere actually. Make this large. Now we have a sphere, and I just want to assign this flat shader to that. Right, so now obviously the sphere gets a projection, right? So if I go inside it, you can see I got my sky. Everything is being projected, right? Which is very great. So I always have data wherever I project on. And that's exactly what I want. For the rest though, I don't want to use a projection. I want to use a light. Because this is a flat shader, it does not get any lights, right? So that's something which is great. We don't want to further illuminate our captured plate. One thing though is our multiplication of occlusion is not there anymore. So we just need to, instead of hook up the spherical projection, we want to hook up the plate projection, which has the spherical projection in it. So this guy hooks up here, and then the out color hooks up to the flat shader, and we should get back the occlusion. Okay, keep going what you're doing. Sometimes like this that makes sense. Computer that works good in the camera projection over the spherical projection. Yeah, okay, so we got all this. So this is kind of all I did in terms of projecting stuff onto my scene, right? Let's see if the occlusion, how that looks. So the occlusion is very large, so it should not occlude there. So let's just change the size maybe to 10, 5, 1. I think 1 is in this case 1 meter, so maybe 2, I don't know. Yeah, anyway, so this should be the occlusion. It should not be overall, so just something like that is better. Okay, so that is that. And the next thing is would need to be is the lights. So let's head over to Arnold lights. And then you just create a Skydome light. on default it's white. So what you can do, you can hook up the spherical right there, or just, I just like to keep it kind of separate, but I guess you can actually just hook up this into color. And now you need to make sure to align it as well. So right now I think it's not really aligned. So this is the red building, and it needs, I guess, to be rotated also by 90. Exactly. So this is correct. That's the back, that's there, and here's the building. Okay. So this lineup is correct. So what you see now is I have all the elements in place. So obviously I don't want to see the Skydome in my camera, so I'm just disabling that. But now we get the lighting. So if I make this visible again, you can see we get this cube. And if I look through my render cam or my shot cam, this is now my floating cube. And you can see it fits in there pretty damn well. It has lighting, it has occlusion, it has all the elements we need. And this is kind of a step to integrate it. So if you want to do a car, you can just place it in here, and you can just, it kind of just works, right? Depending on the frame, you can go further in space, like place it maybe here. And you should also get the correct refraction, you should get the correct bounces. So let's just very quickly do a car, and then people are, I guess, waiting for the good stuff, which is still coming. So let's just quickly head over to I'm just heading over to my resources folder. If I can find it. That's not sorting. Oh, the sorting is always different, but let's just load in a vehicle. It's being loaded in as a reference, so it should not affect scene size, scene scale. It's a big asset. All right, so now we have the car. The car is modeled to scale, right? You can see it's very large. The scene is very small. So we can either scale the car down, I think by a factor of 100, or scale up the scene by a factor of 100. Because I wanted to show some bifrosting, I just want to scale down the car by a factor of 100. So it's I think 0.01. And if you would like to scale the scene up, you would select your stuff, group it all into one group, and scale it up by 100, depending on how you modeled, what scale, what geometry you have. Okay, so here's my little vehicle. Let's just park it right there. It's stretched to the back because obviously my camera could not capture the pixels which are invisible to the camera, right? So that's why it's so long. Okay, let's just assign a shader to this. Standard surface shader. Assign to everything. Hit play. Or hit render, actually. So the default shader is very off, in my opinion. So a normal gray sphere which you shoot on a set is around 18% gray. Has a roughness around 6 for Arnold settings. And this would be the integrated car. You can see it's very dark, but it's kind of accurate as well. So if I move this forward, this is now what we get, right, in terms of the car. Obviously it needs to go down a bit, stuff like that. So this would be the integration of the car. It's a bit dark, so I'm just boosting up the exposure in my render view. And then obviously you would assign glass shaders. So let's just do that quickly. I just want to show you something cool with glass, so that's why I actually wanted to add this. I'm not really sure if we care, but I'm just assigning this for the headlights too. So for glass, you don't want to have any opaque, so you want to have transparent. So switch that off, and in the shader, you just do black, black, no roughness. I don't want to see speck. We want to change this to be glass. You want a transmission on. You go to code, you enable code, do the same glass thingy, and do maybe a roughness of 0.05, something. Okay, so this is now the vehicle, right? The cool thing now is, because we project the plate onto the geometry, if I put my car in front of this vehicle, maybe let's just render through the perspective. You can see that in the refraction, if you can actually see it, here you can see that you will actually get the car refracting properly through the windscreen, which is very cool. Like you can see it's working very good. It is not a fake, like just in the background, it's actually refracting the proper plate. So back to object. So as I said, I stopped it up. It's actually pretty dark. So yeah. And then obviously you would assign shaders and do your look dev and all that. I'm not showing you this in this tutorial. So car paint shader very quickly, a few presets. Let's do a white car. Make this white. And now you can see it kind of fits in this world already pretty good. White car, if I bring down the exposure, kind of like that, done. And obviously because we did not shoot in proper HDRI, we would need to do some more lighting work to get it actually look proper. Maybe the scale is a bit off, compare these cars. But yeah, something like that. Yeah, so obviously we don't have the same lighting, so what you could do, you could create another light and all that, make it work. But kind of this is the integration step I wanted to show. Okay, so now comes the Bifrost stuff, and I hope I still have the time to do it properly, but let's just do that. So all I want to do is just splash some water onto the ground right in front of the camera, right? So I'm saving this. I'm going quickly to my reference editor, and I'm just removing the car. I don't want to do splashes on the car and stuff like that. It's maybe too much. But what I like to do, I just do a splash on the ground. So in the last few weeks, I worked quite a bit with Bifrost just to get some liquid shading, liquid simulation. And yeah, I had my issues at first because I came from RealFlow, and it works a bit different. Bifrost, definitely, it's a bit different, but it's still fun. It's once you grasp the idea, it's fairly straightforward actually. Okay, so I have my one thing is very important in Bifrost. The scene scale should be like your Maya scene scale, should be in centimeters. So that's something very important to get the proper physics working. So my working units is in centimeter, but Bifrost understands 1 centimeter is 1 meter. So that is important. That's why I did not scale up my scene, because I guess this kind of thing, this area here is maybe 10 meters wide, I think. This cube is 1 unit, 1 centimeter in Maya scale. So if I scale it up by a factor of 10, not in Y, just in these two axes, this is 10 by 10 centimeters in Maya, but RealFlow interprets this as a 10 by 10 meter grid. So that's important. Maya centimeter, RealFlow, Bifrost thinks it's meters, right? Okay, that's all I wanted to say. I'll keep my geometry as a collider. That's very important. That's why we solved it. And in the FX menu, you have Bifrost fluids. I'm just, how you say that? I'm just turning off the menu, and I just create a little, let's just hide, or just let's make it not visible. I like to create a little, let's say we just create a cube, or let's just create a disk. Poly disk, it has 32 sides. Doesn't need that many subdivisions. Like that. So this is a, it has a radius of 0.1. So it's actually 0.2. So it's like 2, is that 2 meters? It's not 2 meters. So it's, I guess, 20 centimeters large radius, right? So it's kind of like a hose for like a fire extinguisher or something. So if we put it on 0.5, we get a 1 meter diameter, which is very large. So let's just stick with maybe 0.25, so we get half a meter diameter. So you select your geometry, you head over to liquid, and all that is doing already is hooking everything up. And you should get a liquid group, you get a emitter group, and I think if everything is correct, maybe it's not, because my particles are maybe way too large. In my liquid properties, you have a master voxel grid. You can do it on 0.1 maybe, which is just changing the overall size of a voxel grid. I'm not sure why this is not really my emitter. You can see I did it already too long ago. Forgot how to do it. Let's see. So normally the emitter is, you select it and it already emits from the object. But let's just try it again. So I'm selecting this. Oh, I think the emitter needs to get some love. It's a shell. It needs some thickness. I think. Is that what was missing? Maybe not. Oh, there we go. There was something. Okay. Okay, so depending on your scene scale, you would need to get a different scale of your thickness of your object. If you have a cube, it takes in this as solid. If it's a shell, you need to specify that. So that's why it did not show up. So I just want to make my point size a bit bigger so you can see what's happening. And in the emitter itself, we want to have continuous emission. So it always keeps emitting for this kind of effect I'm going for. Let's see if this is doing it now. Okay, so it is continuously emitting. It's very low res, as you can see. So next thing is to add the floor to as a collider. So I'm selecting my liquid, I'm selecting the mesh, and I'm hitting collider. So that is now, or it should be colliding with the surface. I can disable background, enable scratch disk. So what this is doing, it should cache based on my playback. So if I hit play, it should cache each frame out to disk. Hopefully that's, you can see it's getting green there, so that means it's being cached. Let's see if it actually did it. Doesn't look like it. See, it's a bit finicky to get this to work. Just trying to hit play here, but it does not really solve it. It might be that the emitter, the collider is maybe set to a solid. It should also be a shell actually. And the thickness should be maybe 0.05. Or we can actually keep it on 1, then it takes in the master voxel size. Okay, so that should do it now. So now you can see the particles are falling down based on gravity, and they should actually hit the ground and splatter what it's doing, right? So again, this is nothing really beautiful, but I just want to show you the quick concepts of shading this stuff. We want to add a motion field. It's kind of like it's kind of adding velocity to something. Currently, the liquid is just falling based on gravity. So we want to actually add a motion field. We want to enable a box boundary, so it's only emitting, or it's only affecting it in that box not outside of it. Okay, we want to change my direction of it, so enable it back on. It should only have direction, and it should be, I guess, a -1. Okay, so you can see now the field is pushing particles down. You can scale it to be not as large. Oh, that was definitely too much. If you disable it, you should have a faster response. And it should only speed up the particle, like kind of it's rushing them down towards the ground. So you can then enable it, and you can change a different magnitude. Let's say maybe 15. It's up to you. You got to see what's working for you. And then I just want to create a kill volume, so everything outside it will kill the particles. It's called a kill field actually, not a kill volume. And this should be around my water, like that. And everything which is outside of this will get kind of killed. So we should get a faster sim. Currently it's killing the inside, so there's a invert. There we go. So this is all the setup I'm doing. So then you can add in the motion field as well. You can add turbulences. So let's just bring that in as well. Depending, you can, I think, visualize it somewhere. Velocity draw, that's just a velocity grid. Actually not sure if you can visualize that. Well, it doesn't matter. We have some turbulence. So if I go back to my Bifrost liquid and I go maybe a voxel grid of 0.1, you can see they get a lot denser now. And kind of proper voxels for water in real life is 0.03. It's in feet. So it takes a long while to simulate those. So depending on your needs, you should not really go too crazy on this. You can try to 0.075. All right. So if I hit play now, we will sim it, and feel free to ask any questions, please. In the meantime, like I know simming takes a while, so this will not be the highest of quality, but we should get something hopefully. So yeah, so what I'm doing now is I'm simming it, and then I will add some curvature, and I will add some vorticity and some churn. I think that's all I need. And I want to show you how to use this stuff in your shading network to actually get something going. So you can see the liquid is dropping. At some point it will hit the floor. There we go. And to make things a bit more interesting, I might just add a little object there. You can see it's hitting the borders of my kill box, which is good. And you can see it's not that interesting. Okay, so now water is rushing down, it's hitting the ground, and it's dying off. And if I look through my render cam, let's see actually where we are in space. Somewhere there in the back. It looks odd, but you can see it's nice and tracked and all that. So let's just add a kind of, let's do a cube actually. Like a little bit of an angled cube. So now you can see that it's kind of hitting the surface. We can do something like that maybe. Okay. And obviously we need to add this as a collider. So select my liquid, select my mesh, and add collider. That is being added right now. And the next step would be like in the liquid visualizer, you can see that you can apply a color remap of velocity right now. So a value of 5, you would see that the velocity is increasing once it's hitting the ground. And you have different channels as well. You have density, you've got a air distance, vorticity, velocity. Vorticity is kind of like the inner particles, how speedy they are around each other, something like that. But I want to get churn, which is kind of noise, and I want to get a vorticity channel rendered out. So in my Bifrost liquid properties, you can take on a few optional channels. So you can get churn working, and you can use curvature. So these two guys, they get written into the voxel grid, so you can actually read them from the shader. And one more thing which we can quickly do as well is use volumes to create foam. So if I select my liquid as well, I head over to my Bifrost menu, and I just say foam, which creates a new foam properties thing. And in here you can specify how much foam, where and when it's being created. So when these three factors are met, only then it will generate foam. So minimum liquid speed is 0.2, minimum liquid churn is 1, which is normally pretty high. So if you reduce it by a bit, you get more foam. And curvature is based on the liquid because it's very linear, my foam. I just want to reduce this as well. And this is kind of all you got to do to generate foam. It's only mostly of this, like you can work with these things, but I'm not really that familiar either, so I'm not so sure what they do. All right, but now let's head over to my liquid again. Let's just solve for 50 frames. So what I like to do actually is go to my options and do background processing on, apply and close, go back to the menu, compute and cache to disk. And I just want to do 50 frames like that and create. So it should go from 1 to 50 pretty quick. And after that, it starts simming. And you can see that's what's happening. Yellow is it's about to be cached, and green is it's cached. So you can already see now we get the foam in the viewport. These little white dots there. And I think you should always also be able to make them larger by adjusting the point size. There you go. So now you can see the foam is being generated as we speak as well. You can hide things. You can say, I don't want to see the liquid right now, just hide the particle. So this is only my foam. And then you can also do the same with the foam, hide that, and you only got the water. So this is kind of how it works. You can see now it's hitting the surface, and there's some air between these guys. It's just because my voxel grid is still pretty large. But you can see now it's actually working pretty nicely. It's falling through. Also voxel grid size or a minimum step sizes in my simulation things. But as you go down in my on the voxel grid, you should definitely get to see better solves for this. So you can see now where it's where there's lots of churn or lots of curvature, you get lots of foam. And where it's more like linear, you get less foam, which is exactly what we want. So one last step before we head over to shading this guy. I just want to reduce the master voxel size some more, do the recache. We can go maybe up down to 0.45. And then let's just recache this quickly. It looks good though already. It's nothing crazy, but it kind of works. Okay, so now I change my voxel grid to 0.45. Maybe 0.4, does that update? Ah, it does. So, well, let's just do 3.3. And let's just do some. It might take a while, but we can already start shading at that point. So now we have 31,000 voxels for this guy. Bifrost fluids, compute and cache to disk. Let's go. Overwrite. Okay, so please feel free to ask any questions here. And then while it's caching, I can try to answer them. Yeah, I just ask a few questions in the chat. I'm not sure how quick the live streaming is, if it's accurate. So let's see. Just had to drink some water. Doing lots of talking here today. So we are already 10 minutes, 12 minutes over. But it's fine. I think we're still good in time. So let's head over to the first few frames. You can see now this is what we get. Yeah. So how it works is in the node editor, while it's doing its thing, I will just be creating a AI standard shader. And how you read from the voxels or from the Bifrost stuff is very easy. You just use AI user data color, and all you gotta do is choose the attribute you want to read. Vorticity, for instance. You can duplicate this. You can read churn. You can read curvature. How can we use channels with reflow meshes for shading? I'm not sure how it works in RealFlow. If you mean RealFlow, I'm not sure, but I will show you how to do it with Bifrost. Curvature, this guy was churn, and this bad boy was vorticity. Vorticity. Okay, so for now, I'm just plugging these guys in the ID slots, and they are just placeholders, so I don't want to use ID AOVs or something. I'm just plugging them in so I can read how they look. Like so. And then I also want to have a standard volume shader for the foam, right? Which is a color kind of whitish, and we see. Well, RealFlow is a direct competitor. Bifrost is a direct competitor to Bifrost, and even though it doesn't get any traction, I agree Houdini is used a lot in bigger productions. Smaller studios, I betcha they use Bifrost a lot because it ships with Maya, so they don't worry about Houdini licenses, or they don't worry about RealFlow licenses. They'll just use Bifrost, right? Because it ships with Maya. So keep that in mind as well. So we cached a few frames, so we are hitting the surface. We get some nice liquids. You can see now we are a lot closer to the geometry. And you can see now we get these nice puddles of water. The question is, will you be showing a wet map? I knew that was coming up. I have not yet found a way to actually output that. You can do it in comp though. You can kind of do a reveal map in comp, like with a time offset or something, and just do a difference mat to get a water mat for this. You can do that in comp. But I will definitely figure it out, and I will show a way to do it directly, like to get an output, like a contact map or something like that. Okay, so I will stop the caching now. We are on frame 30. And let's just save this guy and head over to the render. So I just want to disable the caching. So now this is what we get, right? Looks pretty cool. We got the water. We can do a liquid override if we don't want to have these large particles anymore. Foam should be a bit smaller still. Yeah, you can use occlusion as well, for sure. I tried occlusion. It kind of works. So there are different methods to do it, for sure. I think I broke it now. Did I? Not sure where the liquid is. Did I break the water cache now? I hope not. It looks like it. Let's see. Let's see if it's in here still, in my caching. I'm just checking on disk if the data is still there. Desktop. Liquid voxels. It's all there still. So it should be somewhere. Anyway, so let's see what happens if I just hit render, if we can see something. I guess we will see the foam. Let's get to perspective, hit play. Okay, so we definitely see the foam. So for the foam to work, I'm just clicking on the foam shader or node in the outliner, right clicking it, and then I'm just assigning the foam shader, which I have already created. Didn't I create it? Standard volume shader. It's annoying that the liquid is not there, because it actually, the cool thing is you don't need to mesh it anymore. Okay. You can see we already see some kind of particles right there. It's a volume-based shader, so let's see if we can play around with the scale. Point size, let's do maybe 1. Okay, so this is kind of the foam. You see it's very small. You can see it though. It's definitely there. I'm not sure why the density is not working as I would expect it. So density is hooked up. Can play it up definitely by 5. And you can also make the particle size larger and smaller based on the density as well. So once it's in water, you can actually see there will be something going on. Unfortunately, I'm not sure where the water has gone. Why it's not in my cache anymore. You can see the foam is definitely here. I just need to figure that out quickly. Let's see, liquid is there. Otherwise, we can try to enable mashing. See if this still works. Nope. I'm just trying one more thing here in the liquid properties to enable this guy. So this should actually read from the cache. Oh, now it's doing it. Okay. Huh, I was afraid it was gone. Okay, so now we can go back to liquid and just disable the mashing step. So we got the liquid back, which is great. 1030. Okay. So that's the liquid. So for now, I just hide the foam. That's the liquid we get. And let's just assign the shader, which I created here. Assign this guy. Hit play. Okay. So now this is the liquid. The cool thing about Arnold now, it supports Bifrost natively. So it just renders the voxels directly as a liquid, which is very cool. You can see right now we have a little milk shader. But we want water, so let's just do that. So water, no weight. Also, we want the IOR to be water. Water doesn't change. We want no roughness, and we don't want Speck. We just want transmission. We want to have a little color. Depending, you can do green water, whatever. Based on the depth, you can do, this is a 10 meter scale in this case. So you can see we get kind of green water there. And then we want to bring up the coat with 1, and we want an IOR of water as well. So this would be the water shader. So the next thing would be, how do you read from, how do you read velocity, for instance, right? So in the node editor or hypershader, whatever, I hooked these guys up. So if I do render selected, you can see this is now my vorticity. This is my churn, which is not that visible. And I'm not sure why the foam is already still rendered. Curvature, I think we would also need to, so I rendered, oh, we need to make it available as well. So you, first of all, in your properties, you would need to render them out. And then I think in the liquid, you can also, somewhere you need to enable them as well. Let's see if I can find that. It's always hidden. Let's see where it was. Not there. There it is, channels. So you would need to add it to render. So you want to add churn, curvature. Okay, so these are off. I'm not sure why I did render them. Okay, so now we have, let's see if this works now. So vorticity, churn, and curvature. Excuse me. So then obviously based on churn, which is like kind of turbulence in the water, you would connect a range shader. So that's always the first thing I do. I connect a range and I work with the churn. And based on this, you can just say, hey, this is the roughness of the water. So where there's a high churn amount, you want to drive something in the shaders. So this is a value of 0.2. We want to maybe boost it up to be pretty bright. So this is no, it does not go over 1. So this is a value of 1. And in this case, we want to play around with the scatter or something like that. So in the water shader, you can do like scatter, maybe a value of 20. You can see now it gets kind of solid again, right? And I just want to create some murky water for a high churn value. So we have a value of 4, right? This is a value just ranging to go up to 1. So I just disable the clamping. So now this goes up to 1.6. So we can go higher. So this is a value of maybe 3. We can go even further, boost it up some more. So this goes now up to 7 or 8. So this is, let's just connect the red channel. Oh, actually just connect it to the scatter directly. It's not output, so I'm just dragging it over to scatter. And now you can see on the churny parts, you get this murky water, right? So wherever there's lots of disturbance, you get milky water. You can also change the color of the water. You can do the same with vorticity. You can do the same with curvature. So for curvature as well, you do a range. Like that, hook this up. That's kind of the same technique all the time. You would do a nice range, which works for you. And then based on that, drive a shader with this. Okay, so you can see where there's lots of curvature, especially on the front there, you will get a matte for that. And what you can do, you can just connect these guys up together. So this is a value of very low, 0.07. You can go crazy. You can output a value a lot higher than that, 2 or something, and then you can just plus them together just to an AI composite or something. And just do a max. Always takes a maximum value for that pixel, which we want. A, B, out color goes to transmission scatter. Then we have a result like that. And let's do that. And now we get more scatter in these areas. So this is kind of how it's working. And you can do lots of things with this. You can use more vorticity, which is like velocity inside the particles. Let's bring back the foam. Foam is a weird thing. It's very dark all the time. So what I tend to do, I just have a separate light just for the foam, or render it completely separately. Foam itself, as it is right now, is not fully scatter. But you can see based on what we have, it's already there. You can definitely play around with the value here, but at some point it gets too bright, I think. You can see now we get the foam in these parts, and if you play it back, you should get something. You can also try emission. Just use emission color, I think. You can see now this is pretty white for the emission stuff, but it's can do density maybe. Density. So this is now driving the emission based on density. So this is different things you can play with. And obviously this looks more like splashy water because it's a lot brighter, but it kind of works as well. So again, this is my current exposure. And then also what would be nice if you would just render it with motion blur, then you get the streaks already. So if I just stop it quickly and go to render settings and go Arnold and open up motion blur, enable this. Let's say we want 4 keys. And let's render from my object. Okay. Let's just assign a shader for this. And I think this is kind of what I wanted to show for this session. So I definitely showed the integration part. And let's do a 100%. And you can see now with all the splashes, it looks pretty cool actually. And it kind of seems to work, especially we get all the refractions from the cars, and all we had to do, as stated before, is use occlusion to get something working. So the ground setup already incorporates occlusion, right? So this should already do it. And then yeah, you can amp up render settings, go maybe up to 6 or something. Now let's see. Yeah, so I hope this made sense. You can see it looks actually pretty good. Maybe I will render out these 50 frames or something. I think it looks pretty good. You get the water, you get the splashes. It kind of feels like it's actually integrated pretty nicely in this environment. So let me know how it goes. If you want to, if you want to access this stuff, it's on my Patron channel. So if you have not signed up on Patron just yet, you can do so, and you will get access to all the source files of all my previous tutorials. And obviously you will also get all the stuff for this current live session. So you will get this QuickTime here. You can track it. You get my reference images, which I have actually never showed. So you can actually use them as well as a plate projection. If you solve it for that camera angle. I haven't done so yet though. So this would be a raw image from my phone. So you could also use that as a plate. It's all included. So be sure to check that out, and I will upload the Maya scene, but I will not upload the caches. So you would need to do your Bifrost caches yourself. But yeah, so that sums it all up, I hope. So I talked about general integration, solving it in Nuke, all that, and then doing projections, doing occlusions, doing lighting with the sphere, and then we went to Bifrost to do some quick water sim and just showing you how that all works. So now my Saturday starts. It's now 10:30. I talked for 1.5 hours. I'm thirsty. So enjoy the rest of your day, and if you're on this side of the world, enjoy your Saturday, and definitely on the West Coast, enjoy the sun. So I'll see you in the next video. Thank you guys. See ya.